So I'm gonna switch. Okay, I heard switch cotangent into what? Cosine over sine. Okay, then what? Cosine. There's got to be a 1 here, right? And then what am I gonna do? What are we gonna do with the cosecant? 1 over sine. Okay. We're getting close. What's the problem? Why can't I cross stuff out yet? Well, actually, look at what I could do. What's this? Isn't this the top fraction? So isn't it cosine beta over sine beta over cosine beta over sine beta? So is that going to reduce? We did it, you guys, there's probably 5 or 6 ways to do this same problem. We did it a totally different way during the first period. Okay. Also, on the final, you will get the pink sheet that's on the tables. You get to have those out. If you want to have your unit circle, you can have that out. We are going to do degrees and radians on the final, so you might want your actual unit circle. The signs will be up. The other thing you'll have access to, as Dudley and I talked about, you will have access to the sequence and series formulas. You won't have to memorize yourself. Okay. There are little things along the way that you won't have access to, so I'll try to point those out as we go. Okay. Alright. So, you gotta name the trig function that's equivalent to the expression. Where am I gonna get the answer for this?
Pink sine.
So pink sine, so it's 1 minus sine squared. Good. Now, that's not gonna be the problem on the test, right? How could I change it? Make it the same thing. One more time. What could I take out? Put in. What could I write instead of sine?
You can write.
Couldn't I put cosine in instead of sine? Right. That would be the way, an easy way for me to change the problem and give you the same concept, right? Could I have made it 1 plus tangent squared instead? Yeah, and then you just put in the secant squared, right? Okay. So really quickly to change that one. All right, looking at this one's weird, if I remember right. What's problem? It says we got to go into terms of sine and cosine is the instruction, so I might as well just do that. What's another name for cotangent?
Cosine over sine.
Cosine x over sine x. All right, what's another name for cosecant?
Over sine.
Okay, so I'm going to really have cosine x over sine squared x. Okay. All right, we good with 3? It looks weird though, right? That's it, yeah. Because of the way the instruction were, nothing canceled, and it said we had to be in terms of sine and cosine. Okay. Look at the next one. We got to write an equivalent expression. So what am I going to do first? Let's factor out a secant by greatest common factor. So I got secant squared x times tangent squared plus 1. All right. So what is, what can I replace this with? I've got a pink sign, right? So secant squared x. What's secant squared times secant squared? Secant x. You put the first, just the factoring out one? Yeah. You guys got to simplify one. Yeah, I didn't know. Whenever you see this piece right here, pink sign. Alright. Whenever you see something squared plus a 1, check the pink sign. Okay, it might not. There's some of them that don't work, right? It has to be secant squared minus tangent. It can't be the other way around. One in the very middle. But you always check that sign. The other place to check, it's not likely to come up, is on the double angle. remember, it's gonna be all multiple choice if you're not finding it. Go through and scan through looking at it, looking for something you can replace. Okay? That works for any trade. Okay? Just solve the multiple angle. Just do whatever's on the inside and send you to radius. There didn't seem to be, I don't think there's a multiple on today. It's like this one, except that you don't have like a 2x. The same thing you do. Okay. Alright, so it just says multiple angle, it makes it sound scary, right? Alright, I gotta solve this. What am I gonna need to pull out to finish the problem? Unit circle's gonna have to come out, right? Okay. Physically pull out. Alright, what am I gonna do to move the one? I'm gonna add it and then what? Is it possible to skip this step? Yeah. You guys should be pretty close to the point where you're able to move the 1 and the 2 at the same time, especially if you're going on to a higher level class. All right. I gotta use my unit circle now. Is cosine the x value or the y value? X value. So tell me the radian measures where the x value is equal to 1/2.
Pi over 3, 5 pi.
Use that one a lot. Probably have it memorized. Okay, we good with 5? Alright. Am I too fast? Too fast, just let me know. Slow down. So I can have my snap. Might have to make it. Alright, we go with 5. Okay, 6. We're gonna use the fundamental identities to simplify. Alright, I'm seeing squares and a 1. What do I check? Page sign. Okay, so we're looking at the page sign. What am I allowed to substitute in for secant squared minus 1? Okay. So tangent squared x. Am I done? No. What am I going to do now? Okay. Tangent goes to sine over cosine. So we're going to do sine squared x, cosine squared x. Now what happens? The cosines cancel. We're left with sine squared x. Alright, we good with that? Okay, the next one I didn't give you an answer, right? Because you can't really draw a graph at the testing mechanism you're using. Yes. Okay. So we gotta sketch a 550-degree angle at standard position. First thing we need to do is figure out what quadrant the terminal side is going to be in. So how do I get it just into, how do I get a coterminal in?
Subtract 360.
Okay, we're going to subtract 360. So 1 is 550 minus 360.
190.
Okay. What quadrant is 190 going to land in?
2. That's
3, because this is 180 right here, right? It's got to be like in there somewhere. And then remember, it's multiple choice. You're going to be picking from a pictures, 4 pictures. So remember, you have to show you went around a whole 360 and then you kept going and you landed in that quadrant and you're probably going to want to label it 550. It may or may not be labeled. Probably won't. That would be dead info. Okay. You have to go always to you always go counterclockwise. It's negative if you go the other way. So if it said negative 550, we would have gone around and actually landed in the second class. Okay. We would have added 360. Yeah, you would have added 360 twice, actually. Yeah, because if it was negative 550, add 360, that only gets you to negative 190. In order to get to the coterminal spot, you have to add it again. Yeah. You have to at least figure it out. Yeah, for it to be on that main unit circle, it has to be. Okay. Alright. Hopefully I wouldn't do that. Right. I was getting a lot of questions about this yesterday. This is one thing that you will not have access to a formula on the test. You have to know it. Alright, so you need to make sure you study this. It's not a hard thing once you know it. There's when you see this degrees to radians or radians to degrees, there's 2 numbers. It's pi and 180. You just have to figure out which one goes where. Okay? If we're going to degrees, we got to get rid of the pi. So where's the pi got to go?
Bottom.
On the bottom. says to get rid of the fraction, right, if we're going to degrees. So what goes into 12 and 180? You can just multiply it across, right? You could multiply across. What if you don't have a calculator on it, though? That's what I'm going for. Right? I'm sorry, you said 4 went in, right, MJ? So 4 goes in there 3 times and into here 45 times, and then 3 goes into 45. So could I divide 12 into 180? But without a calculator, I might have had to do it twice, right? How many times does 3 go into 45? 15. So I'm multiplying 5 times 15, which is 75 degrees. All right. Good with me? All right, I'm thinking of taking this one off the test. It's just too hard. Yes, you have to do it on the calculator, okay? All right. We have to convert to decimal form. We're going to use the degrees, minutes, seconds. Clear what's there so you're not tempted to use somebody else's. Okay? Hit a dot B. All right, I'm going to hit a dot B too. Double check to make sure your calculator is in degree mode. Okay. So how do we change it? We go to Home, Settings, Dock Settings, and then switch your angle mode to degrees. The make default. Okay. Then what I'm going to do is I'm going to come back here and calculate. There are 2 places you can get it from. You can go in the button next to the book, and it's the second column in the middle row. Click that. You could have also gone to the book, and it's under 2, and it's degrees, minutes, under the angle, it's degrees, minutes, seconds. You can get it from there as well. Sorry. Button next to the book. AP is in speedy mode right now, so Alright, so I'm just going to type in my numbers. Now I'm going to type in 34 degrees, 22 minutes, and 15 seconds. And I'm just going to hit enter and see what happens. How'd I get there? The button next to the book, and this one right here. Okay? Got it? That's the shorter way to do it. You could also do it off the book button. Right now, that's not what our answer is. They wanted us to go to decimal. How do I get it in decimal? What do I push? Could I push Control Enter to begin with? I could have pushed it off of this line right here, Control Enter, and I would have gone to the decimal. So 3 decimal places. Oh, it says 3 actually. Obviously go off your multiple choice. So 34.371. Probably be able to guess your answer. You should just say for the degrees. No degrees. Make sure the float on it under the menu is more than 1. Floating is 6 or 8 right now. Alright, we good to 9? Okay. Now, do you want me to leave it on the test or should I take it off? Should leave it on. Alright. Exact value. There are 2 ways we can do this problem. We could use our Pythagorean identities up there and our other trig identities to do it, or we can do triangles. Want to do triangles? Okay, so we're going to go back and live in SOHCAHTOA world as we're doing this. So I'm going to draw a triangle. I'm going to label it theta. In SOHCAHTOA world, what is sine? Opposite over adjacent. So I gotta go 15 opposite, adjacent 17. How do I get that third side? Pythagorean theorem. Okay. Or you have it memorized. I'm guessing not as many of us have this one memorized. So 8 squared plus 15 squared equals 17 squared. I probably use this one here, so I can use 5, 12, 13, or 3, 4, 5 on the test. Okay. Alright, so what is 15 squared?
225.
And 17 squared is? 289. So we have, we're going to move the 225. Subtract it, so it's 289 minus 225.
64.
And I'm going to undo this square by doing what? Square root. What am I going to do now? Do I need a plus minus on this? No, we don't get a plus minus because they're not. It's not a part of geometry like that, right? It's square root of 64. 8. Okay. That was important because in order to get secant, I need the adjacent, right? So secant is what in SOHCAHTOA? Hypotenuse over adjacent. So my hypotenuse is 17, my adjacent is 8. Alright, we've only got 5 left. Alright, we okay with 10? Alright. I think this one's really tough too. I might take it off. Alright, it says use the calculator to evaluate the function. We're supposed to go 4 decimal places, it says this time. Okay, so let's try that in the calculator. It literally says the cosine of that degrees, right? So we're going to go to trig. Trig cosine, and it was 24.5, and you should be in degree mode. They told me 0.9100 last week. Okay. Technically, you're supposed to have 4 according to their instructions. Probably be able to figure it out. So 20, sorry, no. 0.9100. Alright. There's 2 ways this problem could be solved. Okay? You could use one technique if you had a calculator, one technique if you didn't have a calculator. Okay? So I'm going to go for the non-calculator technique first, and then I'll explain something you can do if you don't remember this formula. This formula will not be anywhere on the test. You have to know it for this problem. Okay? So remember how we had 30, 60, 90 right triangles, and we had a short leg, and a long leg, and a hypotenuse? Okay, so we'll write the formula down one more time. The long leg equals the short leg. Does anybody remember? Square degree. The other one for that one is hypotenuse equals the short times 2. We don't need this one for this problem. Okay, we only need the first one. Alright, so what's on your long leg? Y. Good. What's on your short leg? It literally is just plug it in, isn't it? There isn't anything to it if you know the formulas. Okay? Now, you have to do it that way if you don't have a calculator on it. And you might know at least ahead of time, maybe. I don't know how nice I'll be to tell you which ones are which days. But we'll see. Okay. See how I'm feeling with that. And if I've written the final one right. Alright, Miss Dudley probably be like it. Alright, the other way to do it is, couldn't I use tangent of that triangle?
Yeah.
So I've got an opposite and an adjacent. So if I had a calculator available on the question, I could use tangent of 60. Good, and then to get the y by itself, I multiply by. Okay, so, and then you plug the numbers into your calculator, you're going to get a decimal answer. If you do it this way, but your answers look like this, you can use your calculator to go down all the answers and figure out all these decimal points. It's not the short way to do it, right? It's kind of a long, convoluted way to do it, but it's a technique that works. Okay, a testing technique that works. Remember, this isn't just, we don't always just teach just to our test. Think about SATs. If you didn't remember this formula for the SATs, you knew how to do this, you're going to have a calculator out likely. You can figure out all those decimals. Okay? All right, we good with 12? Okay. 13. We're only doing 3 more here. It says we aren't using a calculator. What does that mean we're going to use on this problem? That's a unit circle value, isn't it? So is cosine the x values or the y values?
Yeah, it's,
The x values. How am I measuring this? Degrees, so I need to know where my x values are equal to negative square root of 3/2 what degrees?
50 degrees and 2
Okay. The next one's weird. Are we okay? Okay. I use my unit circle. Right? Because this is the x value, look at that x value, and tell me this time we didn't do versus three. Not a whole lot of written work, a lot of brain. Alright. You know how to do this problem. It's the wording that makes it weird. Okay? What does it want us to find?
cotangent.
Write it down. Cotangent of what angle measure?
Look at 2 pi.
If it was written like that, you knew exactly what to do, right? It's because of the phrasing that people give us the wrong. I don't understand that. Okay? But it will probably be phrased more like this on the test. Just know that it's got to convert it to this. Alright, I'm going to show you 2 ways to deal with that angle. I need it, the negative 2 pi over 3 is not on my unit circle. So I need to figure out what it is coterminal to. How do we do a coterminal angle?
Add 2 pi.
Okay, we're going to add 2 pi in over 3 world. What does 2 pi look like?
Those are 4 pi.
6 pi over 6. We're adding that together, so we end up with what? 4 pi over 3. Good. Cotangent. So we're really also, it's really the same as saying the cotangent of 4 pi over 3. What quadrant do we land in? Third. Okay, so third, and I want the cosine divided by the sine. So it's the cosine in that third quadrant. Good. Good. And the sine is,
Negative square root of 2.
take a minute, pause. Okay, what does that happen to the double negative?
We go positive.
What else happens?
We multiply.
2's cancel, so I get 1 over square root of 3, and I have to rationalize. Or you recognize what that is compared to your multiple choice answer, right? Alright, there's another way to do it, or at least to start it. So when we started talking about unit circle, we started talking about counting in the negative direction, right? You already have labeled negative pi over 3 on there, right? Couldn't I just count 1 more third? Make sure you use the over 3 values and figure out where negative 2 pi over 3 is. And then you use the coordinates right there. Okay, so either you do the coterminal thing or you count the wedges. Okay, we did that a long, long time ago when we first introduced unit circle. Okay. Alright, I am looking for, well, one more. Last one for the day. Alright, what do we know about arc tangent and tangent?
Yeah,
This one's too hard, I think we should take it off.
I like the challenge.
Like, Elmore wants a challenge.
I like challenges.
Anybody else okay for the challenge?
But not the test.
Alright, there were 2 problems from tomorrow's that I said to skip, right?
18, 19.
I think I told you guys about it. We're gonna get rid of 18 because it's a stats problem and 19. Sorry, those snuck in there. Well, the mode is easy.
It's
So we're not
14.
gonna do it. We'll talk standard deviation will probably be the first day. Okay, I'm done talking. Your job is you need to get the next 15 cranked out, right? So we have them in before you come to class tomorrow, so you can start working through that. If you need stamps, you can come see me. Okay.